Okay, I'm going to do a marginal video here on chain rule derivatives, and I'm assuming you know how to do power rule and your trig functions and all that stuff. So yeah, let's just get it started. Basically what you're going to do is you're going to take, we pretty much have a trig function. If you think about it and kind of bend your head a little bit, you could also say that we've got, an inner function right here. And that's kind of how they do it, okay? So if I was going to go f prime of x, it doesn't, I can do the inside first or the whole thing first, but let me just do it because, the example's the best. Well, derivative of sine of anything is cosine of anything. Okay, so I'm just going to go ahead and write cosine. But now I want to take the derivative of the inside and I want to multiply it by what I've got right here. And that's just going to be 2x plus 0. Okay. So there I am right there. And that's not too bad. We got this... we just kind of use a chain rule. So now I'm going to throw a pretty wacky one at you. I'm going to go natural log of the natural log of sine 3 theta. How's that for you? Okay. First of all, d dx of natural log x equals 1 over x dx ddx. Okay, I don't know if you know that little piece of information, but it's a really easy derivative. It's just and it uses the chain rule every time. So you're just gonna, whatever's inside the logarithm, you're just gonna write the reciprocal of it, and then you're gonna take the derivative of x. Maybe it's something not x like this. Something crazy. So what are we gonna do first? Well, the first thing we want to do is we want to take the derivative of the entire thing, okay? Well, that is going to be equal to 1 over natural log sine 3 theta, isn't it? Okay? See, I took whatever was inside the logarithm, okay, which was another logarithm of a trig function, and that just went down to the denominator. Do you see how that happened? Okay? Alright, so now I'm going to multiply it by the next chain, and the next chain actually goes inside, this other inner function, which is natural log of another trig function. Or I mean the same one really, but it's just, we're just using the chain right here. So let's just write, what's the derivative of this? Well, that's just 1 over whatever's inside the logarithm, okay? In this case, it's sine 3 theta. Now we're going to keep going, okay? And we've got another kind of chain here. I might have to, we've got right there, okay? Well, sine theta. Now I need a derivative of sine 3 theta. Well, that's cosine 3 theta. And now I need to go back. Oh man, I ran out of colors. I guess I'll use this little pen here. Now we got to find the derivative of this guy, right? This 3 theta. So it doesn't end there. It ends there, okay? So let's go ahead and clean this thing up a little bit, okay? So it looks like we're going to have 3 cosine 3 theta over sine 3 theta times natural log of sine 3 theta. Okay, now I can actually say that, that is the derivative, okay? Be careful that, sometimes you'll just be doing some algebra, you'll be figuring out some of these weird things, and you'll see this trig function here, and you'll want to factor it out or something like that, or you'll want to, you'll want to do something. And technically, I guess we could cosine 3 theta, we could say 3 cotangent over natural log. And remember when I was talking to you about, trig identities, it's good to be able to do that, okay? Because basically, you kind of got this guy in here, really, and you can kind of do something with him. But don't just remember that this is one piece right here, natural log of the trig function. So let's see, how much time do I have? Do I have time for another one? Maybe let's do a more a mellow one. I mean that one was kind of intense, especially if it was your first chain rule. So let me think of another one. Let's go. Let's go y equals secant of 2 theta. What's the derivative of secant? Secant tangent, right? That's how I remember it. I just go secant tangent. So let's go secant 2 theta, tangent 2 theta. Now we just use our chain rule, and we go times 2. Okay? So we could just say 2 secant 2 theta, tangent theta. Now say we were interested in secant tangent, in the derivative of this function at pi over 4, just to make it easy. 4 pi over. So 2 secant 2 theta, so 2 pi over 4, that's just going to be pi over 2 is what that's going to reduce down to. And then tangent of I forgot to write that 2. That's going to be tangent of pi over 2. Okay, so let's kind of rewrite that. We'll just go 2 cosine pi over 2. And then we got sine of pi over 2 over cosine of pi over 2. And let's see. This is going to go to 0. This is going to go to 0. This is going to go to 1. We end up with 2 over 0. Well, if we go ahead and graph this thing, it looks like at pi over 2. And by the way, I have secant. Oh, it's the opposite of cosine. Cosine of 0 is 1, so it's gonna kind of look like. Wait, no, I'm sorry. It's gonna look. Yeah, it's gonna be like something like that, or is it? Yeah, but anyways, basically, when you run into this 0 in a trig function, you just know there's going to be an asymptote somewhere. Something's going on like that. So, and that's all that means. So, if you ever evaluate a trig function, I mean, I just guessed, I made one up, and we kind of got a good example of a vertical asymptote. So, almost out of time. More chain rule derivatives on the way. Keep rocking.